Hello, this is Jongert of Superuse Studios. Very happy to be here today with all of you. I'm going to tell you a little bit about Superuse Studios and tools we developed amongst Harvest Map that we use for the sustainable circular architecture that we're working on. So we're a team of 12 people based in Rotterdam. That's where our core is. Next to that, we have a studio in Beijing and one on site that is working on several projects, supply housing projects across Europe. And we're with 15 people all working on cases that I'll show you shortly. One of our inspirations is actually the enormous amounts of blues every year. This is a graph by an organization from Canada that shows yearly how much value is lost for steel, for aluminum, for food, since we throw away 1/3 of all our food is $1.2 trillion per year of losses. These are enormous amounts that we think can be used much more beneficial, and we try to create value in these losses. Even the renewable energy that we generate today actually has a big loss, which are the windmill blades that are changed every 10 to 15 years if they are working well. And then was a graveyard of wind turbines, because the energy that we generate with it maybe might be renewable, but the materials that have created them aren't at all. So this is a graveyard in the US of the first thousands of windmill blades that are, and this is happening all across the globe. In the Netherlands, we also have them. We cut them, and then they end up in incineration plants. And even those incineration plants are not very happy because they harm the installations. For many years, Superuse already exists since 1997. We have been incorporating these flows of materials into new architecture and design. And for instance, those wind turbine blades to us offer a great opportunity to create inspiring playgrounds. This was the playground in Rotterdam that we realized, where 5 of those wind turbines were adapted. Some holes were cut. We connected them to existing parts already in the playground and turned them into a very nice new playground. Into urban furniture like these slightly smaller windmill blades that actually give very functional seating in the city of Rotterdam. Or like this, wind shelters next to the sea. How wind turbines are designed these days is pretty different from how we did this 400 years ago. Here you see a typical historical example of Dutch windmills from 1600. Beautiful buildings, intelligent, I would say, than the ones that we are building these days, because they harvest energy locally. The energy that is harvested is used on site to either grind corn or to create new products, and even a shop is inside. So it is also a mix of functions in one building. And next to that, the building itself is built in such a way that it can easily be dismantled, and when it doesn't function on this site, it can be taken apart and moved to another site. Well, different from the windmills we're building these days. As Superuse Studios, we're trying to get back to this kind of building, to actually learn from how those blades have been built, and design buildings made out of materials that we can find in our. And one of the first buildings that we designed was a villa in Enschede, which was made out of 60% of reclaimed materials. And for this house, it was also the first time that we used the term harvesting, where we started to harvest around in the neighborhood, either from construction sites or from local industry. And this harvesting resulted in a map like this, with a section of a house, also indicating where what kind of materials we had been using, like a steel construction out of industry, insulation material from another building dismantled. And on the right side, you see a section of a detail actually indicating where all these materials ended up. One of the materials we used for this house, which is also one of the parts that makes the expression of this house, are cable reels. They're wasted every 5 years after the use, carrying cables for infrastructure. We see this as a beautiful resource for all kind of wood constructions. The wheels might be not so usable, but the wood inside can actually supply a couple of square meters of facade. And again, what happens these days is that it ends up in furnaces, creating biomass energy, as we call it. But we actually think there's a much better opportunity to actually save the quality and the value of this material in a much better way. And on different types of ovens that actually don't incinerate it, but heat the material up to such a point that all the sugars get out, and that the lifespan of this wood is extended by 5 to 8 times. So now our cable reels are turned into the wood being able to function as a facade. This is a picture of last year when we celebrated the 10 years anniversary of Villa Welplo in Enschede, which actually shows after 10 years how this material that you can see on the facade actually behave. I like this to get inspired by the size of these materials. So it's not just the material itself, but also the size actually defines the way how we design our facade. As you can see here in the horizontal lines that actually are the cuts between the different slats of wood that we found. Well, in this villa, we really worked this theme of Superuse through to the smallest detail, up to lighting fixtures that are made out of umbrella beams. Another product that typically only lasts for 3 months, but in this case, we collected umbrella beams and turned them into lighting fixtures that already last 10 years, and the value obviously has been risen from maybe a €5 umbrella to an €80 lighting fixture. Funny thing is about that this way of building is not something new. We discovered by Vincent van Gogh, the famous painter, over 150 years ago, just before the Industrial Revolution started, where he actually painted an auction of the Church of Nuenen. This is a village where he was living at the time, and he, in the middle, an auctioneer selling the different parts of a church that has become redundant. And the local villagers actually bid for these materials to use them in their houses. So this is how before industrialization and also the digital technology development happened. And we tried to actually, because of course the scale of everything has been risen a lot since then, we actually use current technology to actually reinvent older principles. And the harvest map is one of our first tools that we started developing. After 15 years of working in this way, we had over 200 sources in the Netherlands that actually gave us, that were able to supply us with materials. We thought, well, this is a very good way to actually turn this into a map ourselves, but we imagined many more architects would be able to use type of resources. So that's why we developed the harvest map, or oogstkaart in Dutch, which indicate sources that we found. When we built this, we made it in such a way that we could also use it for other countries. But so far, we're picking up a little bit in Italy, the Netherlands, and in Austria. What typical material is published on Harvest Map is, for instance, this steel material from steel industry. This is what remains after of cutting out different pieces. And we think, well, why transport this around the globe and turn it into new steel? Well, you can actually immediately use this material. In this case, we use it for a fence next to the villa in Enschede. And here, in London, where we turned it into two entrances for a public garden. And we, of course, used local steel for this. And we started looking at different suppliers of this material and also found larger scale suppliers. So, for instance, truck factories that have material in large quantities. We connected this flow of material to a commission for a waste collection center. So here, 1,500 square meters of this material has been applied for this project. And what's interesting is that this, for the first time, was a project that was commissioned on the base of the highest level of otherwise wasted materials to be turned into construction materials. So we won the bid, supplying them with, again, over 60% of these kind of materials. You can also, on larger scale, so for a housing corporation, we indicated how many resources they actually own in all of their housing. The 20,000 houses, which is half of their stock, actually supply for almost 12 towers, 25 meters high of materials. Here separated in wood, concrete, and brick, etc. So this gives a harvest in the city of the resources they actually own. And we actually scaled this, really knowing how many window frames they have, 16,000, how many toilet seats, how many doors, etc. So actually this gives the housing corporation an inventory of what they own, and if they start to restructure their housing, they can either use this or use this for new housing they're developing. And we supply them with a strategy to use Harvest Map and a construction supply market, a building hub that actually makes the connection between the supply and the demand, not just of their own housing, or of their of other suppliers within the city. The good thing is that because of this, we found a way how to actually change our the steps that we do during design process. I'm sorry, this is in Dutch, but what it shows is sketch design, and then after we have a sketch, we start harvesting the materials. With the harvested materials, we come to a preliminary design part, working on what do we actually buy from the Harvest Map. We create a dynamic definite design in order to allow other materials to be found during construction. And after we realize it, we count the environmental impact that we are able to realize. It's not always about construction materials. We also sometimes end up finding an industry like a beer brewer, having waste, spent grain, for instance, that can be used by a bakery in order to bake bread. So our scope is not on the construction industry and construction materials, but also we're looking at what kind of products are actually produced within the buildings. And this leads to a different philosophy, which is a little bit different from the circular economy. You probably have seen the image going from linear economy to recycling economy from the 70s to a circular economy that is now being promoted, which tries to prevent waste and create endless loops of materials. We think that sometimes materials will not have a function, but actually will be stored at some point, and new companies can actually create new products with it. So the blue economy, that's the one that we're actually trying to create many different types of values and also contribute to the natural environment instead of harming it. Well, the place where we actually collect this knowledge and that we initiated is a former swimming pool in Rotterdam. It's a tropical swimming pool that is now being redeveloped into a hub for companies all working on the blue economy. We designed like a master plan for the redevelopment, which will be executed over time and change every year. Especially now with Corona, we have actually a high speed of redevelopment because there's no one that is bothered by the construction. This building, we actually also managed to have 90% of all the materials to be actually taken and harvested from the Netherlands and the region around Rotterdam. But by doing this, we calculate with the company also in Blue City the CO2 emissions that we are able to reduce, and we're able to actually reduce our impact with almost 70% compared to using new sustainable by actually just using what's already there. Next to this, I said we also have a company in China, 5 young architects on projects like us. The interesting thing is that the scale is much bigger, so we also have to think of different tools how to apply them in China. We came up with a Chinese harvest map some years ago that also has a collection of materials, but of course the amounts are 10,000 times higher than we encounter them in the Netherlands. Like for instance, this window frame company that wastes 200,000 euros of new materials every year because of wrong orders or the overproduction they have. There's around 3,000 of these companies within a 40-kilometer range of this companies. This is over €1 billion of loss of value every year that is not used because there's no harvest map. And that's, of course, what our harvest map is trying to overcome. And then we're also looking at larger scale industry. How can we not just use materials for construction, but also actually connect different industries to each other, a little bit like what we did with the bread and the beer brewer. We connect different industries that have waste with the resources of others. And in order to do this, we designed a tool called PulseApp. The different companies to see each other's waste and resources. And we're hoping that this actually helps open companies so that not just larger companies, but also smaller ones that identify a waste flow that doesn't get value, actually can create new value, new products, and new services with it in order to prevent the waste and increase labor and also have good value with it. Well, to conclude with, I will show a large project we're currently working on that actually integrates most of the ideas we have been collecting so far. This is a blue city like in Rotterdam, but then again 20 times bigger in China. This actually is an industrial zone where we collect the materials to start constructing of a water purification plant. We use resources from the water purification plant to create brick for the building, but also the program that is installed here that actually starts to interact with each other. So there's no large-scale factory, but the facade allows the different industries to exchange resources with each other. And in order to do this, we also have a harvest map to, of course, collect these materials, but also the company, it's like the resource valley, as it's called, has its own harvest map that shows which company has what kind of resources, so they can actually start to resources within their company. Well, to give you a little bit of overview of Superuse Studios, our current development is that the harvest map in the Netherlands is now transferred to a large deconstruction company, so they will actually start to upscale the projects or the harvest map that we developed. They have a lot of resources buildings that are published on this, so for architects and construction companies, it will be much easier to find proper materials and start materials, so that the projects we've been doing can also be can also be started up by other architects and other constructors. We see actually quite a bit of traction on this happening, especially since the 2050 environmental goals that the government set. You now see housing corporations, construction companies, developers also wanting to move into more what is then called circular construction. So we are, apart from realizing our consulting these other projects, we sometimes make specific harvest maps for companies and write information and strategies to also develop their own projects. Next to that, also offspring is that we can also supply harvest map to other industries. So, for instance, green filmmaking is filmmakers in the Netherlands that wants to start to grow the greener film industry. So they adopted harvest map for their own industry and actually show where renewable energy can be found, or different props can be found, and where they can actually separate their waste. So the harvest map gets a different function on different spots for different industries too. Well, this and tools that we have been developing and the partners we're working with, I hope this gives you a good to join the workshop tomorrow about harvest map. This gives inspiration to design a small house. Having the waste that is everywhere around us in large quantities around us, and to turn them into an exciting aesthetic value. Good. Yeah, we're now working with different residential projects. So housing corporations start to adopt this. One of the problems is that sometimes it's more expensive because more labor is involved, and we're now trying to actually help the government move to a shift in taxes, so that labor will be taxed less and resources more, so it will become more profitable to build according this way. But already we're now working on 3 housing projects with over 50 houses. So this is not something that is impossible, even for new construction sites. All of it is possible. We made it in that way, the first version open source, so that everyone could supply the materials. But of course, we first put in resources that we found in the first 15 years of doing our projects. So also the knowledge that we find in our projects, we don't waste it, but we put it on a map so that others can access it. But by now, the new harvest map that's just launched, it has materials that are from larger deconstruction sites in the Netherlands. So it will be populated with many more products. No problem. Um, So what we do is we visit companies, we some municipalities to look at the industrial zone. We have statistical information that actually we can predict the data of resources and waste. So that's for each industry, we know more or less what is going in and out. But we also on the floor check these data with reality. They never match. And then we see what's really going in. So we are just very interested in how those processes work. And of course, every project we do gives us more information about these resources. So the question of Maria is how do we actually guarantee the quality of the materials? For a construction material, we have, for instance, kind of logical knowledge like wood. Yeah, if you use wood either new or second hand, it doesn't really matter for the quality. We sometimes, like for instance, with the villa in Enschede, we upgrade it and then we get the guarantee from the company that actually the modification to the material. But also with steel, for instance, we take a little bit larger margin with the structural consultant that we hire. The calculations, and they for second-hand steel they take like 10% more structural quality that is needed in order to reach the structural integrity. So we list also for this, and sometimes it's just a matter of logical thinking, um, yeah, to use this. No, sorry, and now I missed the name, but um, Aliki, she asked whether every can be regenerated. No, this is not the case. Like some have been polluted with really harmful chemics. To give an example, for the villa in Enschede, we first thought to use railway sleepers, beams that carry the rail tracks. But we found out that they are actually chemical treatment that is not very harmful, but too harmful to be used in housing. So then we decided. Of course, we are longing for a future where these kind of hybrid chemical hybrids are not used. So that's why we also promote the bio development of materials, so that we can actually to use every material that is on our track. So the second question about the fashion of different tools. I don't completely get the question. Sorry. Destina asks whether it's a main public or private suppliers of materials. This depends. Most are companies, so either demolishing, deconstruction companies, or the owners of the buildings. Sometimes it's municipal deconstruction that is taking place, so we have those. Mainly private, but the interesting thing is that also they are of course interested in a higher value for their materials. Sometimes they have to pay, or often they have to pay for deconstruction and the low processing of the waste. So if we can pay them a higher amount than they would otherwise get, they would also be interested. This is, for instance, the case with the steel that I showed. Normally, a waste company only pays 25 cents for a kilo of this material. We can pay them 50 cents per kilo for this material. So offer a cheaper material to the client of the building. So everyone has a benefit in this. It's just that no one knows the resources and the qualities and quantities, etc. of them. Thank you. Thank you for your support.